So in this lecture we're going to look at a little trick that we can do in physics, which actually is one of the aspects of physics that I do enjoy. If we have two equations that link a particular variable, so we've got two equations we've looked at here, we've got resultant force equals mass times acceleration, and we've got acceleration equals change in velocity over time, we can actually combine these two equations. That's what we're going to do now. So if we know F equals ma, but we know a equals v minus u over t, we can actually substitute this a in this equation with what we know a to equal. So this whole part of this equation can be substituted in here, and we can end up with the equation F equals m times v minus u over t. And we can multiply out the brackets to then give us our final equation. F equals mass times the final velocity minus mass times the initial velocity divided by time. And we know that mass times velocity is momentum. So here we have a final momentum, because that's our final velocity, take away an initial momentum, because that's an initial velocity, divided by time. And that can give us the force that is required to change momentum by those amounts. So we can write this equation again in words, and we end up with the equation force equals change in momentum over time, or final momentum take away initial momentum divided by time. And we can put that into practice. So we have a question here. It says a 2,000 kilogram car accelerates from 5 meters per second to 20 meters per second in 10 seconds. What resultant force produces acceleration? So we need to start substituting our numbers into our equation. So we're working out force. So we know the mass is 2,000 kilograms. We're multiplying it by the final velocity. So it's v in our equation first, which is 20 meters per second. And then we're going to subtract from that our mass again, 2,000 kilograms, multiplied by the initial velocity, which was 5 meters per second. And we're going to divide all of that by the time it took, which is 10 seconds. So that leads us to 40,000 minus 10,000 divided by 10, which gives us 30,000 divided by 10, which gives us a force of 3,000 newtons. Don't forget the units at the end. So all we've done there is read the question and substituted in these numbers from the question for the correct symbols, and then worked out the calculation following. So we'll try another example looking at something slightly different. This equation can also be used to work out the force that is felt upon impact, or a change in momentum. So we have a 60 kilogram gymnast falls from his equipment onto a mat. He hits the mat at 3 meters per second and takes 0.25 seconds to come to a stop. So his final velocity is going to be 0. What force does he experience? So let's have a look. We know that force equals his mass times his final velocity. Remember, he's coming to a stop. Take away his mass times his initial velocity, which is when he hit the mat, which was 3 meters per second, divided by however long that took, which was 0.25 seconds in this example. So we have our force equals minus 180, because this is 0, so it just disappears. If you multiply anything by 0, it becomes 0, divided by 0.25, which gives us a force of minus 720 newtons. The negative sign is just because we said the positive velocity was in the downwards direction, and when he hits the mat, the force he feels is in the opposite direction. So the minus sign just indicates the direction of the force, but the magnitude of the force he would experience is 720 newtons.